August 15th, 1977, Ohio State University. There's this radio telescope called the Big Ear. It's a wonderful instrument, actually. They've been using it since 1973 to search for signals from extraterrestrial intelligence. The SETI program, you know? And this is a serious scientific endeavor. These aren't crazy people. These are astronomers doing legitimate research. Now, this particular night, this radio telescope is pointing up at the sky and it's listening. What it's listening for is radio signals at a very particular frequency, the frequency of neutral hydrogen. And why that frequency? Well, that's actually quite clever. Hydrogen is the most abundant element in the universe. If you're an alien civilization trying to communicate, where would you broadcast? At a frequency that almost anybody sophisticated enough to receive you would probably have, and hydrogen is universal. So that's the logical choice. That makes sense. Now here's where it gets interesting. A few days later, one of the astronomers, a fellow named Jerry Ehman, he's looking through the computer printouts. They printed out the data, you see, back in those days, and he finds something very unusual. The signal intensity is printed out as a series of numbers and letters. And remember, 1 through 9 represent signal strengths 1 through 9. After that, you go to the letters A, B, C, D, and so on. And what Ehman found was a signal marked as U. That's 30 times the background noise level, 30 times stronger than the noise around it. And he's so surprised, he writes, "Wow," right there on the printout. And that's what it's called now, the wow signal. Now, before we go any further, let's think about what this signal actually was. The telescope detected it for 72 seconds. That's the full window during which the telescope was able to observe it. It came from the direction of the constellation Sagittarius. And here's something important, and this is what made people think it might be artificial. It was narrowband. That means it came through in a very narrow frequency range, not spread out all over the place like natural radio sources usually are. And it had a pattern. It started low, grew, and then decreased again, which would make sense if it was coming from a direction you're pointed at, sweeping across as the Earth rotates. You'd expect that kind of pattern. So Ehman thinks, and you can understand why, that maybe, just maybe, this is something artificial, something from elsewhere. It has all the hallmarks you'd expect from an alien transmission, the right frequency, the right intensity, the right pattern. It's very exciting. But here's where science comes in, and this is the crucial part. Here's where we have to think carefully about what we can actually conclude. The first thing you want to do when you find something like this is you want to look for it again. You want to see if it repeats. This is fundamental to the scientific method. If it was there once and it's real, you should be able to find it again. You should be able to point the telescope back at the same location and catch it once more. Not necessarily immediately, it might be intermittent, but you should see patterns. You should be able to establish that this is a real repeatable phenomenon. So what happened? Well, they looked. They looked very carefully, in fact, and they never found it again. Not once. Think about that for a moment. Here's a signal 30 times stronger than the background noise, and it never comes back, ever, not even close. And this is crucial because it tells us something important about the nature of what we're dealing with. Now, what could this mean? Well, let me lay out the possibilities, and let's think through each one carefully. The first possibility that occurred to people was maybe it is aliens. Maybe some civilization out there sent us a signal, and we happened to catch it. Maybe they were broadcasting once, and we got lucky. Or maybe they were testing their transmission and only did it once. And yes, that's possible. That's not impossible. But here's the thing. If you're going to spend the resources to build a transmitter powerful enough to send signals across the galaxy to a planet you're not even sure has anybody on it, why would you only do it once? Why not do it multiple times? Why not maintain regular transmissions? And the fact that we never found it again suggests that either there's nothing there sending it, or whatever was sending it has an explanation we haven't thought of yet. The second possibility is maybe it's terrestrial interference. Maybe it's something from Earth. Maybe it's a satellite or a communication system or some radio station interfering with the observation. Now, they did check for this, and the pattern of the signal seemed to rule it out because it had this crescendo and decline that would make sense for a celestial source, not something near Earth. But terrestrial interference is always a possibility you have to rule out carefully. And then there's the third possibility, and this is where it gets really interesting scientifically. Maybe it's a natural phenomenon that we don't fully understand yet. Maybe there's some astrophysical process that can produce a signal that looks a lot like what we found. Maybe it's not aliens, and maybe it's not interference, but some genuine cosmic phenomenon that just happens to produce a signal at this frequency. Now, for a long time, we're talking decades, nobody really had a good explanation for this. So it became this tantalizing mystery. People speculated about it. Some people became really convinced it was aliens, and that was sort of the conventional wisdom. The wow, signal remains unexplained, so it might be aliens. But here's what I want to tell you about, because this is the exciting part for me as a scientist. In recent years, people have actually started to figure this out, and I think it's worth understanding what they've found. A few years ago, some astronomers were looking at data from the Arecibo Radio Observatory. This is between 2017 and 2020, so much more recently. And they're using more modern equipment and more sensitive detection methods. And you know what they find? They find signals that look very, very similar to the WOW signal. They're much weaker, but they have the same characteristics. And all of these signals seem to come from hydrogen clouds, neutral hydrogen clouds in space. So what's happening? Well, here's the hypothesis they came up with, and I think it's quite elegant, actually. The WOW signal might have been caused by a sudden brightening of a hydrogen cloud. Picture this. There's a cold cloud of hydrogen gas out in space somewhere, and then a transient energy source illuminates it. Maybe a magnetar, that's a neutron star with an extremely intense magnetic field, has a flare, or some other intense energy source. And this energy excites the hydrogen atoms in the cloud. Now here's where physics gets interesting. When you excite hydrogen atoms, when you pump energy into them, they can undergo something called a Moser effect. Moser is like laser, but it works for microwaves instead of light. The atoms can amplify the radiation and emit a coherent, concentrated beam of energy at the hydrogen frequency. And if that beam happens to be pointed directly at you, it can look incredibly bright and intense, even if the total energy being released isn't that extreme. It's focused, you see? It's concentrated. And this would explain several things about the WOW signal. It explains why it was so intense, 30 times the background. It explains why it was narrowband. The Moser would produce radiation in a narrow frequency range. It explains the pattern of intensity. As the source brightens and then dims, the master output would do the same. And most importantly, it explains why we've never seen it again. These events are rare. They require a specific alignment. You need the energy source, you need the hydrogen cloud, and you need Earth to be positioned just right to see it all at once. The probability of that happening twice is much, much smaller than the probability of it happening once. Now, I want to emphasize something here. This explanation is a hypothesis. It's not confirmed. Some scientists still aren't convinced, and that's fine. That's how science works. You propose an explanation, and then you test it, and you see if it holds up. But I think what's important is that we now have a plausible natural explanation that fits the data. We have something that we can work with scientifically. And here's the beautiful part about all of this. The fact that we've come up with this explanation doesn't mean the search for extraterrestrial intelligence is pointless. Not at all. In fact, what it does is it teaches us something crucial. It teaches us what kinds of signals we need to watch out for. It teaches us about false positives. It teaches us how to be more careful observers. You see, the WOW signal was detected by just one telescope at one moment in time. Nobody else saw it. Nobody could repeat it. And this is a lesson for future SETI research. If we're going to claim we found something truly extraterrestrial, we need multiple confirmations. We need different telescopes to see it. We need it to be repeatable, or at least to show patterns that make sense. We need to be rigorous about ruling out natural explanations before we jump to extraordinary conclusions. Now let me talk about something that I think is very important when we approach a puzzle like this, when we approach a mystery. There's a human tendency, and I'm not criticizing people for it, it's just how we are. There's a tendency to want the answer to be the most interesting one. We like mysteries. We like the idea of aliens. It's exciting. It captures our imagination. But as scientists, we have a responsibility to be skeptical of our own desires. We have to ask ourselves, am I believing this because the evidence really supports it? Or am I believing it because I want it to be true? And that's a hard thing to do. It's genuinely difficult, but it's essential. Because if you don't do it, you start seeing patterns that aren't there. You start interpreting data in ways that support what you want to believe. And that's not science, that's wishful thinking. What I find really interesting about the story of the WOW signal is precisely this journey we've gone through. We found something strange. We didn't understand it. And rather than just accept that it was mysterious, rather than let it stay as an unsolved puzzle forever, scientists kept working on it. They developed better tools. They gathered more data. And slowly, the mystery became less mysterious. But here's the thing I want you to understand. This doesn't make the discovery any less valuable. The wow signal is still one of the most important events in SETI history, because even though it probably wasn't aliens, it taught us something real. It taught us how to think about unusual signals. It taught us what we should look for and what we should be skeptical about. And I'll tell you something else. The fact that we can now explain the wow signal doesn't mean we'll never find a real alien signal. It just means that when we do find one, if we find one, we'll need to be much more careful about proving it. We'll need multiple confirmations. We'll need to rule out every alternative explanation, and that's actually a good thing. That's how science works best. You have a problem, you work on it, and your tools get sharper. Think about what we've learned from all of this. First, the universe is a strange place. It produces phenomena that can fool even careful observers. A natural astrophysical process, a hydrogen cloud being illuminated by a magnetar flare, can produce a signal that looks like it could be from an alien civilization. Nature is creative. It comes up with things we don't expect. Second, we have to be humble about what we don't know. In 1977, when Ehman found that signal, nobody could explain it. And it's okay to say, I don't know, when you don't know something. But you don't stop there. You keep looking. You keep thinking. You keep working. And third, the search for extraterrestrial life is still a valid and important scientific endeavor. Even though the wow signal probably wasn't aliens, the fact that we're looking, the fact that we're developing better methods, the fact that we're learning to distinguish between real signals and false positives, all of that matters. Somewhere out there in the universe, there might be other intelligences, and it's worth looking. It's worth thinking about. It's worth doing the work to figure it out properly. Now you might ask, well, if the wow signal wasn't aliens, why did you call this video the alien signal from 1977? Why did you get me excited about aliens in the title? And that's a fair question. I'll tell you why. Because the wow signal is perhaps the best example we have of how science actually works in practice. It's a perfect case study in the scientific method. You find something strange, you get excited, and then you do the hard work of trying to understand it. You rule out possibilities, you come up with hypotheses, you test them, and you follow the evidence wherever it leads, even if it's not where you wanted it to go. And that journey, that process, is more interesting to me than any definitive answer would be. Because science isn't about being right. Science is about getting closer to the truth through careful observation and rigorous thinking. So here's what I want you to take away from all of this. When you encounter something mysterious, something that seems impossible to explain, don't just accept the first explanation that comes to mind. Don't assume it's the most exotic possibility. Do what Jerry Ehman and the other astronomers did. Look carefully, think critically, and be willing to follow the evidence. Develop better tools, ask better questions, and most importantly, be willing to change your mind when new information comes in. The universe is full of mysteries. Some of them will turn out to be something wonderful and strange and completely new, and some of them will turn out to be natural phenomena we didn't understand yet. But either way, the process of figuring it out, that's the real thing. That's where the joy is. That's where the discovery is. That's real science.